Hello, good morning everyone. My name is Shilcha and today I'm going to give a presentation on homogeneous equations in education. And yeah, coming to the topic, introduction to non-homogeneous equations. Non-homogeneous equations are mathematical equations that include a non-zero term. They play a crucial role in various fields including physics, engineering, and economics. Understanding these equations is essential for students engaging in advanced mathematics and applied sciences. This topic is generated to our students since the eighth class only. It's a very important topic in laying basics and to generate more algorithms or complex structures. It also plays a main role in physics, engineering, and economics too. They are used to analyze algorithms and different situations to do different variables and usually in matrices also. These are equations which include non-zero term, which means not a zero term. In generally in homogeneous equations, the output comes to a zero, but in this the output is not equal to zero. And yeah, understanding the equations is essential and required for students engaging in advanced mathematics and applied sciences. And coming to definition of non-homogeneous equations, non-homogeneous equation is in the form of Ax is equals to B, where A is a matrix, X is a vector of variables, and B is a non-zero vector. Uh, Unlike homogeneous equations which have solutions that pass through the origin, non-homogeneous do not. Recognizing differences in different types of equations is pivotal for solving them directly. Like you need to understand the difference between homogeneous and non-homogeneous equations. In homogeneous equations, the solutions pass to the origin. The origin is equal to zero. Origin is always equal to zero. Well, in non-homogeneous equations, they do not. So that's why in homogeneous equations, ax is equals to zero, and this in this it's not. Uh, because the equation doesn't pass through the origin, the output is not equal to zero. So we need to recognize the difference between these two to effectively solve the problems with using these the both methods of homogeneous and non-homogeneous equations. And yeah, in these equations, non-homogeneous equation in the form of X is equals to B. Where A is a matrix, B is a vector, B is a non-zero vector, and X is a vector of variables. And yep, coming to its importance in education, non-homogeneous equations are fundamental in teaching students critical thinking and problem-solving skills. They provide real-world context, allowing students to understand complex phenomena through mathematical modeling. Incorporating these equations into curriculum helps students develop a robust foundation in mathematics and related fields. This is a very complex structure. There has many methods to solve it. Just there are five methods to solve homogeneous equations itself, and also there are many complex algorithms in it itself too, and there are also uses of many different complex practices. So this in using to solve this may enhance students' critical thinking and problem solving skills. By teaching them students this, it may also provide real world context you can use to apply the equations in real world situations to solve complex phenomena through mathematical modeling uses. And yeah, incorporating these equations into curriculum helps students develop a robust foundation in mathematics because these are very hard. By help, if you are able to solve this, you may have ease in further solving any other complex equations too. End up coming to its applications in real life. Non-homogeneous equations are applied in various domains such as engineering in for modeling forces and movements. In economics, they help in analyzing supply and demand relationships in market equilibrium. Understanding these applications can inspire students to appreciate the relevance of mathematics in daily life. And yeah, mm, these have applications of in various domains such as engineering can use them these homogeneous equations to modeling, and it can also use to analyze different organisms and different structures, and you can also use them to model different types of forces, etc. If in economics you can use this homogeneous equation non-homogeneous equations in analyzing supply and demand relationships between and how to maintain equilibrium between these zones. Uh, because economics deals with the sales stock, etc., like how the products are selling and how they are being bought. This by using these equations, you can see the equilibrium, like what is the rate of difference between these two and the such as the ratio. And yeah, understanding these applications in real life, you can appreciate the value of these mathematics and how they can be applied in different world contexts. It may enhance your creativity to use different mathematical topics on the real life and use them to understand the real world context too. And yep, coming to teaching strategies, educators should use interactive teaching methods such as problem-based learning and to engage students with non-homogeneous equations. And incorporating technology like graphing calculators software can enhance students' understanding of this complex problems. Real life applications and case studies should be integrated into lessons to demonstrate practical significance of non-homogeneous equations. And yep, teachers or lecturers should use interactive teaching methods such as problem-based learning to like making students to solve problems to make them understand non-homogeneous equations properly. Incorporating technology such as maybe some visual examples or graphing calculators or using devices or software to demonstrate the usage of these concepts can enhance the students' understanding of the concept itself. Real life applications and case studies should be demonstrated and shown and explained further deeply in order for the students to properly understand the significance of these non-homogeneous equations. And coming to the common challenges in using it, students often struggle in recognizing the structure of non-homogeneous equations and differentiating them from homogeneous ones. As I stated at the start, understanding the difference between non-homogeneous equations and homogeneous equations is important in solving it. Students often struggle with this topic itself. Misunderstanding the solution methods such as particular and complementary solutions is a frequent hurdle. Educators must address these challenges to targeted instruction and additional practice opportunities. Uh, yeah, coming to assessment techniques, assessments and non-homogeneous equations should include a mix of theoretical questions and practical problem solving tasks. Formative assessments like quizzes and group projects can help to gauge student understanding throughout the learning process. Providing feedback on students' approaches to solving these equations is vital for their growth and comprehension. Hmm. There should be different assessments done on this, which include a bunch of theoretical questions and also practical questions in order for them uh, to improve the problem solving and also understand the topic in itself. Formative assessments like quizzes or group projects, which may improve the community and also may in the group projects, if you interact with different people, you may also understand what is their view on the topic, which may enhance your view itself. It in turn may improve your understanding in the concept. Providing feedback uh, asking your teachers to provide teachers asking you to provide a feedback, the students feedback, which may help the teacher view how they are viewing the concept. If there is any misunderstanding they are having, teachers can solve it to improve their further understandability and also improve the comprehension of the topic. Resources for educators. There are numerous online platforms and textbooks that provide comprehensive resources for teaching non-homogeneous equations. Professional development workshops can equip educators with innovative strategies to teach these concepts effectively. Collaborating with colleagues to share resources and explaining and teaching techniques can enhance the overall educational experience. Yeah, coming to future trends in education. As technology evolves, the integration of software and simulations in teaching non-homogeneous equations is expected to increase. The use of data analytics will allow educators to tailor instruction based on individual student needs and performance. Emphasizing this interdisciplinary approaches will enrich the understanding of non-homogeneous equations across various fields, such as technology is going on improving, the integration of software into this concept, which may simulate in teaching non-homogeneous equations more effectively and efficiently. The use of data analytics will allow educators to tailor instruction based on individual student needs. Uh, and by using different sorts of data analytics, we can also see how much they're understanding, how much they're getting topic, etc. So we can schedule our like instruction method based on that. And yeah, interdisciplinary approaches such as making a strict structure and a uh, instruction practice, which may improve like the understanding of it over all various fields. And coming to the conclusion, a solid grasp of non-homogeneous equations is essential for students pursuing higher education in the STEM fields. Uh, Educators play a vital role in fostering this understanding through effective teaching strategies and resources. By addressing and utilizing varied assessment methods, we can enhance students' mathematical engineering skills and mathematical literacy and problem solving skills. Yep. Thank you. Thank you for listening to the presentation.